This week on Ask an Expert, the moon. Welcome to Ask an Expert, the show where you submit questions to be answered by people around the school. I'm your host, Kieran Lanois. This week on Ask an Expert, your question is, what would happen if there was no moon? Here to answer your question is Mr. Hecht, a former future astronaut. Welcome, Mr. Hecht. So, can you help us with this question?
Sure. So there's a couple of different questions actually in there. The first one is maybe what would happen if Earth had never had a moon? And the second one is what would happen if the moon disappeared now? Mm-hmm. So we'll talk kind of a little bit about those. But the first thing I want to talk about is kind of the relative size of the Earth and the moon. So the first thing we have to understand about the moon's influence is that the moon is actually fairly huge compared to Earth. So if Earth was the size of a baseball, the moon's about the size of a ping pong ball, which if you look comparatively, I mean, it's a fair amount of size. So for comparison's sake, if this was Mars, let's say, Mars has two moons, but they're tiny. They'd be the size of a grain of rice compared to the size of Mars. Okay. So when we're talking about the moon being the size of a ping pong ball, you can see it's actually fairly big. Now, it's also farther away. Like Mars's moons are really, really close to it. If this is our scale, these should be separated by about 7 feet. So like it's way far away. But it's huge, so it has a big influence on what goes on the Earth. So there's a couple of things. Let's start maybe with if the moon disappeared right now. So obviously, like a lot of stuff would be the same, but depending on how the moon disappeared, if it just all of a sudden winked out of existence, the biggest thing that we notice would be the tides. So if you live near the ocean, which in Saskatchewan we don't so much,
really have to worry about that.
Our tides are influenced by the moon. So if the moon disappeared, the tides would shrink. Now, they wouldn't disappear entirely because some of our tides are actually affected by the sun, but they would reduce in size to about a third of what they are now. The second thing is, again, because the moon is so big compared to the Earth, it actually pulls some of the water away from the edges of the Earth and towards the middle. So there's a huge bulge of water in the middle of the Earth that if the moon disappeared, that water would all spread back out, and so it would get a lot deeper at the poles. The other thing would be, like at nighttime, the moon is the brightest thing in the sky, right? Yeah. By an order of magnitude. And so we'd have to get used to doing everything in a much darker kind of sky. Now, in cities and stuff, that's not going to make a big difference. But if you're out in the countryside, long walks by the moonlight and that kind of stuff, not going to be able to do that anymore. So yeah, those are kind of the things that would happen if the moon disappeared nowadays. If we'd never had a moon, there's some other things that would have happened in the first place. So like if the moon was just never there, one of the things that it's done over the billions of years that the Earth and the moon have been around is it's actually slowed the rotation of the Earth down. So when the Earth was formed, it spun much, much faster than it does now. Even when the dinosaurs were around, it was a little faster. So like we've got a 24-hour day now. At the time of the dinosaurs, it was a 20-hour day. And back when the Earth was formed, it was like a 10-hour day. So if the moon had never existed, we would never have slowed down from that. So you'd have 10 hours a day, 10 hours a night, 10 hours a day. So that would change a lot of things, I imagine. The other thing is most planets actually wobble on their axis. So if you know the Earth is tilted, right, at 23.5 degrees. And the moon keeps us pretty stable because, again, it's huge compared to other moons in the solar system. And if we didn't have the moon, we could have wobbled all the way down to 45 degrees or up past through the vertical. So, I mean, that affects things like our seasons. Like if we're down at 45 degrees and orbiting around the sun, we've got one side that's pointed towards the sun for half of the year and then away from the sun for half of the year.
So, like, the North Pole could kind of be like where British Columbia is, and like Florida could be closer to the equator?
Well, that's part of it. You would just see, I mean, it would be much, much hotter on the side that's pointed towards the sun, and much, much colder on the side that's pointed away. But the other thing is, we might not have had continents in the way that we have them now. When the moon was formed, and a Mars-sized object smashed into the Earth to form Mars, part of what it did was it kind of stirred up the liquid inside, and the moon, as it goes around the Earth, keeps pulling at that inside of the Earth. And so that's one of the things that keeps the inside of the Earth liquid, is the amount of energy that the moon is putting into it through gravitation. And so it's possible that we wouldn't have continents that move around the way that we think of it now. So imagine an Earth that's spinning, 10 hours a day, 10 hours a night. It wobbles on its axis, and the continents maybe don't move at all. So you're looking at a much, much different planet than what we have now without the moon.
So would there be any benefits to not having a moon?
I can't think of any right off the bat. I mean, tides maybe are something that cause problems sometimes, because you can get a spring tide when the Earth, moon, and sun are all lined up. And so the moon and the sun are all pulling the water in one direction. And so that makes the tides much, much higher. But really, in terms of life on Earth, not having a moon, I don't think would have a ton of benefits. Even humans, like if we had managed to develop as humans without a moon, think of things like our calendars. Like all of our months are based on the moon's rotation, right? And the phases of the moon. And that kickstarted science. People seeing that the moon repeated the same thing over and over again kind of got us thinking about cycles and cycles of nature and those sorts of things. Also, it's a stepping stone to the rest of the solar system. Like if we hadn't looked up and seen the moon in the sky, would we ever have thought to create space flight, that we could go visit it and those sorts of things? So yeah, I'm not sure that there'd be any benefits to not having one.
Okay, well what about the bats and owls and other nocturnal animals that kind of come out at night and depend more on the moon? How much do they depend on it?
Well, again, the moon is kind of the brightest thing in the night sky. And there are, as you pointed out, there's a lot of animals that are adapted to work at night. Now, those animals evolved before we had artificial light. And so if you take away the moon, like humans' eyes are actually pretty sharp. We can operate without any moon. I mean, we know this, right? You've ever gone out when there's a new moon out into the middle of nowhere, you can still kind of see, right? Yeah. We have enough vision that we can operate just by the light of the Milky Way. But there are some animals that require the light of the moon in order to hunt or to build their nests or to do all sorts of things. So if the moon had never appeared, I mean, those animals just would have never evolved. If the moon disappeared now, yeah, there'd be some environmental impacts to that because those animals that are adapted to that amount of light wouldn't be able to operate with a much reduced light coming from the stars and that sort of thing.
Wow. Before I ask any more questions, what made you so interested in astronomy? Well, I think like every kid when you're growing up, you want to grow up and be an astronaut or something cool like that, right? So that was me. When I was about 7, I remember watching on TV the Challenger disaster back in 1985, and a teacher was actually on the space shuttle that blew up there. And so, I mean, not that kind of spurred me into interest for space, but I certainly became more interested in it because I was like, oh, there's regular people going up into space. And so that made it a lot cooler. Plus, I'm a huge nerd, so I like learning things. That's awesome. Same, but we're kind of going to go kind of in the opposite. What if the moon was closer?
Okay, well, so that would have some negative effects then. I mean, again, we talked about kind of the distance between these two on a scale model would be about 7 feet. So you're talking, like way, way far away. If you got it closer, all of the gravitational effects would be stronger. So things like higher tides, because gravity propagates on the inverse square ratio, which means that the closer it gets, it actually the force of it actually goes up by the square, not just, it's not like, it's kind of, it gets math complicated. But really, I mean, if you move the Earth, the Earth and the moon closer together, the effects that gravity has would be a lot stronger. Now, also the other thing would be the light, right? Yeah. The amount of light coming from the moon would be magnified because it would be reflecting over more of the sky at the same time. Interestingly, when you line up the Earth, the moon, and the sun, the distance that the moon is at the moment makes it appear about the same size in the night sky as the sun. Well, not the night sky if the sun's up at the same time, obviously. But that's why you get a complete solar eclipse, right? Yeah. So if the moon was closer, it would cover even more of the sun when it comes in front of it. Similarly, if it was farther away, you would see more of the sun around the edges of the moon when you had a total eclipse. So moving it closer, I mean, yeah, the eclipses don't happen frequently enough that would be a huge effect, but certainly that would be something that you could watch for. And then you have those other effects that I talked about, where like the tectonic shifts and that sort of thing that are happening because of the moon's gravity, and because it's so large compared to the Earth, those would be enhanced. So probably like more volcanic activity, more earthquakes, yeah, those sorts of things.
And much higher tides, correct?
Yes, yeah.
Oh, wow.
So maybe more flooding farther inland, like the tides are kind of what form the shoreline, right? And so if you had higher tides, the water would be flooding inland, farther, higher up, that kind of stuff.
Okay.
Yeah.
Well, you probably weren't. I don't know your age, but I'm probably going to guess you weren't watching when people were actually on the moon.
No, I'm not quite that old.
Oh, okay.
I have seen the footage, but not live.
So do you think it was important for us to just go, like, walk on the moon, like, research-wise? Because we haven't really gone there since 1975.
Yep, you're right. I think it was important. As I said, it's kind of the stepping stone to the rest of the solar system. So all of the things that we learned about going to the moon, we will eventually use, if we decide to go to Mars or any of the other outer planets. More than that, though, I mean, I think the technology race that happened between the Soviet Union and the United States in the run-up to going to the moon gave us some technologies that just wouldn't have happened otherwise. The moon also can be a base for launching missions to the rest of the solar system. Because the moon's gravity is less than Earth's, it's a 1/6 of the Earth's gravity. When you go there, it doesn't take as much fuel to get off the surface of the moon. So if we built a permanent moon base and then use that to launch missions to Mars or to the asteroid belts or something like that, it becomes a lot easier and cheaper to launch from the moon than it does to launch from the Earth, because the gravity of the Earth means that you have to expend a lot of energy to get off the surface of the Earth.
So the moon could basically become the biggest airport, basically.
Yes. Yep, for the rest of the solar system.
Wow.
Yeah.
Well, that's super interesting. Thank you so much for answering our question. Hope to see you again another time.
All right. Well, thanks for having me.
Okay. That's it for this week's Ask an Expert, but we're always looking for new questions. Tweet them to @PACarlton with the hashtag AskAnExpert, and we'll find someone who can answer it for you. See you next week.